Now let us see the problem number 4 on the gear trains, and here we have the question. The figure shows an epicyclic gear train. So this is the given figure in the question. Pinion A has 15 teeth and is rigidly fixed in the motor shaft. So here we have a pinion wheel A which is fixed to a rigid shaft of the motor. The wheel B has 20 teeth and gears with A and also with annular fixed wheel D. So here we have a wheel B which contacts with A as well as with annular wheel D which is fixed. Next we have pinion C has 15 teeth and is integral with B. So here we have pinion wheel C which is integral with B, that is nothing but the wheel B and C are the compound wheel. So here we have C and B being a compound wheel. Gear C mesh with the annular wheel E. So in the figure you can see that this gear wheel C meshes with annular wheel E, which is key to the machine shaft. The arm rotates about the same shaft on which A is fixed. So this is the arm what we have, so which rotates about the same shaft, that is nothing but on which A is fixed. So about this shaft arm A is going to rotate and carries the compound wheels BC. So here it carries the compound wheel BC at this end. If motor runs at 100 rpm, find the speed of the machine shaft. So that is the first parameter we need to find. Next, find also the torque exerted on the machine shaft if the motor develops a torque of 100 Newton meter. So these are the two parameters we need to find. So first parameter to be found is speed of the machine shaft. So next we have a given data, that is from the given. Here we have number of teeth on wheel A is 15, number of teeth on wheel B we have 20, and number of teeth on wheel C as 15. So next we have the speed of wheel A as 100 rpm and torque as 100 Newton meter. So this is the given data what we have. So first let us find speed of the machine shaft. So first we need to find number of teeth on wheels D and E. Since pitch circle radius is proportional to number of teeth and the gears have the same pitch, we have to consider this. So from the figure, if we look into the radius of wheel E, so here we have radius of wheel E, so we can say it is radius of wheel A plus radius of wheel B plus radius of wheel C. So this is radius of wheel B, and from here we have radius of wheel C. So radius of wheel E is the sum of radius of wheel A plus wheel B plus wheel C. So we obtain this equation, RE is equal to RA plus RB plus RC. Since pitch circle radius is proportional to number of teeth, we can write ZE is equal to ZA plus ZB plus ZC. And we know the number of teeth on wheel A, wheel B and wheel C as 15, 20 and 15. So number of teeth on wheel E, we get it as 50. So this is the number of teeth on wheel E, ZE. Also from the figure, for radius of wheel D, we can write it as RA plus diameter of wheel B. Diameter of wheel B. So we can write RA plus 2 times RB. So since this circle radius is proportional to number of teeth, we can write ZA plus 2 times ZB, which is equal to number of teeth on wheel D. So ZD is equal to 15 is the number of teeth on wheel A, and as on wheel B we have 20. So 2 into 20. So we get number of teeth on wheel D as 55. So this is the number of teeth on wheel D. Next, to find the speed of the machine shaft, we should get the equation of speed for different gears, and that is we are going to find through the tabular column method. In the tabular column method, first we have condition of motion, and in the figure we can see that at the center we have arm G. So first column we'll write it for arm G. That is only we say arm, nothing is indicated with the arm, so we call it as arm. Next we have at the center the gear A, so it is gear A. Next we have compound wheel B and C, so we write compound wheel B and C. Next we have gear E. Next we have gear D. So moving away from the center, we write in this order the tabular column. So first we'll fix the arm and we'll give one revolution to the immediate next gear. So in the condition of motion, I write fix arm and give plus one revolution to gear A. So arm is 0 because it is fixed, and gear A I will write it as 1 since I have given one revolution to gear A. When you look into the figure, gear A meshes with the compound wheel BC, so it comes in contact with gear B. So in the compound gear I write minus ZA by ZB, since wheel A is the driver and wheel B is the driven, so driver divided by driven. So number of teeth on driver divided by number of teeth on driven gear. Negative sign indicates that wheel B will rotate in the opposite direction of wheel A, so minus ZA by ZB. And look into gear E in the figure. So gear A will come in contact with compound gear BC, and C will rotate or engage the gear E. So for gear E we write minus ZA by ZB into ZC by ZE. And here we write only ZC by ZE because E is the internal gear. Because of that, C and E will rotate in the same direction. B and C are the compound gear. So once A rotates wheel B, that is nothing but in turn B will rotate C. B and C will rotate together, and C will rotate gear E. Since E is the internal wheel, C and E will rotate in the same direction. So it is minus ZA by ZB into ZC by ZE. Next for gear D. For gear D, if you look into the figure, A will rotate the compound wheel BC, and wheel B is in contact with gear D, so which will rotate the gear D. So here we write minus ZA by ZB into ZB by ZD. Since D is the internal wheel, B and D will rotate in the same direction. ZB will get cancelled. We write minus ZA by ZD. Once we finish the first row of the tabular column, next step is multiplying the x with the first row. So multiply x with 0, we get 0. Multiplying x with plus 1, we get x. Multiplying x with this parameter, we get minus za by zb into x. Multiplying x with this parameter, we get minus za by zb into zc by ze into x. Multiplying x with minus za by zd into x. Once we finish the second row, we add y to the second row. So adding y plus 0 is y plus x, y plus this parameter, plus into minus will become minus, therefore y minus za by zb into x. Next y plus this parameter, negative, so minus plus become minus, so y minus za by zb into zc by ze into x. Next y plus this parameter, minus plus will become minus, so y minus za by zd into x. So with this we obtained speed equation for the different gear. Since in the second bit we want the speed of the machine shaft, the machine shaft is geared or keyed to the gear E, we need to find the speed of gear E. If you look into the equation of gear E, here we have y minus za by zb into zc by ze into x. So here we know the parameters of number of teeth on different wheels, but we don't know the value of y and x. To obtain the value of y and x, here it is given that speed of the motor, that is speed of the pinion A is 100 rpm. The gear A speed is given in the equation y plus x. So we write y plus x is equal to 100. So let us call this as equation number 1. And for gear D, we have the equation y minus za by zd into x. So here we have written that equation. Substituting the parameters za as 15 and zd as 55, we get y minus 0.273x is equal to 0. So let us call this as equation number 2. Considering equation 1 minus equation 2. So equation 1 we have y plus x is equal to 100, and equation 2 we have y minus 0.273x is equal to 0. So equation 1 minus 2 will give us y plus x minus y minus 0.273x is equal to 100 minus 0. That is, on left hand side is equal to right hand side. So simplifying this above equation, that is cancelling y, and x minus minus will become plus, so we write 1 plus that is x plus 0.273x, we will get 1.273x is equal to 100. Therefore we get x value as 78.6. Substituting x value in the equation number 1, we get y plus 78.6 is equal to 100. So simplifying this, we get y is equal to 21.4. Since we know that arm rotates at a speed of 21.4 rpm in the same direction as that of the motor shaft, that is, this is the speed of arm. What we obtained is the speed of the arm, because arm speed of the arm is given by y. we obtained y as 21.4. Therefore, arm rotates at a speed of 21.4 rpm in the same direction as that of the motor shaft or pinion A, which is given. Next we have the speed of gear E. This is equation we have obtained in the tabular column. So here we will substitute now value of y and x. So y value we have 21.4 and x value we have 78.6. So speed of gear E or wheel E is equal to 21.4 minus ZA as 15, ZC is 15 divided by ZB is 20, ZE is 50 into value of x 78.6. We obtained the value of speed of gear E is 3.715 rpm. That is, speed of the machine shaft is 3.75 rpm, same direction as that of the shaft. Next bit is we need to find torque exerted on the machine shaft. That is nothing but torque exerted on the shaft of the wheel E. From the energy equation we have torque A into speed of wheel A plus torque E, that is torque on E, into speed of E plus torque D, and speed of D is equal to 0. Here we have not considered compound gear BC because there is no external power transmission from the gear BC. Therefore we have not considered. And next what we know is gear D is fixed. Therefore speed of gear D will become 0. Hence this parameter will be 0. So we left with torque A and speed A plus torque E and speed E is equal to 0. It is given that torque on wheel A is 100 Newton meter and speed is 100 rpm plus torque on E we have to find into speed of wheel E we obtained as 3.715 rpm. So substituting these values we obtained the torque E is equal to negative 2691.8 Newton meter. So that is the torque on the machine shaft is 2691.8 Newton meter, which acts in the opposite direction of the machine shaft. The negative sign indicates it acts in the opposite direction of the machine shaft. So this is the solution for the given problem.